what's the difference between Snowflake's architecture and the traditional ones. Okay, so as you can see on the screen, like this is the traditional data architecture basically. So just by looking at it, we can see it's like looking as a complex web of technologies. So like many organizations, the basic task of like this data architecture is like we want to capitalize on data and reduce the cost and complexity of data sharing. So basically taking the data from the sources on to tell the target. As you can see in the diagram, so like there are number of layers through which the data is passing before it is transferred from source to target, and each point of connection is a possible data failure. So it is basically a complex web of technologies you can see on your screen, like across the integration, transformation, aggregation, and every delivery step. Actually, like multiple tools have been deployed, as we can see in the picture, and like each point, as I said, is a possible point of failure. So we actually narrowed down to three things here. That are the main thing I would like to mention. So governance, security, and silo issues. So these are like the common issues that we have in the traditional architectures, and like multiple copies of data actually eventually emerge to like meet the various needs depending on the parts of the business. But in the end, basically the main problem that we have in these architectures is like we spend more time managing the infrastructure and less time actually working on the problem. So that is like a plus point that Snowflake offers. So we'll actually have a look at the Snowflake platform, like how the architecture is there. So we can basically compare between these two things. So having said that, Snowflake platform actually, as you can see here, it supports various data sources like semi-structured, structured, unstructured data, and it delivers it up for like wide range of users, including ad hoc analysis, real-time processing, and data monetization is also supported. And yeah, as I say, it's cloud agnostic, so it's supported across all the leading cloud platforms. And we basically, the architectural complexity, the three things that we mentioned, governance, security, and silo issues, those are addressed here in Snowflake. So it's basically you need not concentrate much on the setting up of the things. It's basically you just focus on what problem you need to solve and develop the logic for that. That's it. So this brings me to the functional architecture of Snowflake. So as you can see on the screen, the middle part is the common data that will be accessed by all the teams that will be working. So when I say all the teams, so they'll be using the different warehouses. So all of them would be working on the same common data set that's available. So let's go one by one. So if you can see here on screen, first is the data science team. So the data science team will have their dedicated set of resources, and they will actually use as and when required, and they can release it as and when needed. So after that, you can see we have the data transformation. So data transformation is basically all the ETL work that is being done. So the data is being taken, transformed, and then being loaded into Snowflake, or when we need that, when we need to do that, so they can actually have the warehouses assigned and just deassigned as and when required. So you can see the next marketing analytics team. So they actually, they might need like to process the data to have their build the reports, the BI reports, which can probably help them in their marketing campaigns. So that is another set of team that we will be discussing here. So as you can see, so the data science team, it is using a large data warehouse, and then we have the data transformation team using a smaller one. The data for data loading, that is like structured and semi-structured data, we are having an extra small data warehouse. So the thing that I need to discuss is like for all the workloads, all the teams, they actually selecting the warehouses according to their needs. The data science team actually came to know that they actually have less workload that needs to be addressed, so they can have a large warehouse and then increase it to an extra large when needed. And once the work is done, they can actually again reduce it to a large one. So now talking about the marketing team, so if they have a medium warehouse, so for example, they have another resource that joined the team and they want to speed up the marketing campaign, or like they have some deadline for this time they need to complete all the reporting and all those things. So they can actually deploy another person and assign the new resource another warehouse. So without the resource contention. So they like two of them will be working separately from each other so that they are not interfering with each other's resources. So that is a good thing to have too. And if I go about like now the data science team, they have an Excel one. So now if their work is done, they don't need it. So they can just release the resources, and that would be another thing. And now that brings me to secure sharing and collaboration of data. So if I talk about sharing and collaboration of data, so like in Snowflake, we can exchange data through secured views, and we can actually exchange access data to in the Snowflake data marketplace. So the Snowflake data marketplace, that is basically a readily available set of data sets that are available readily for us to use. We just need to log into data marketplace, and we can just without downloading all those data sets, we can actually work on those. So we can share the data amongst our employees, amongst the business ecosystem that we have in our organization, or with our clients too. So that is the other point. So after that, there is a feature of that is called cloning in Snowflake. So with Snowflake zero copy cloning, users can create multiple copies of the data, tables, schemas, and databases, and without actually replicating the data itself. So this gives the customer the ability to almost instantly make the data available to use for like multiple user groups, like without the additional cost of time and actually replicating the data. So how it actually works is, so like Snowflake stores the data in like files that are immutable and encrypted as a part of the architecture itself. And the cloud services layer that we mentioned in the Snowflake architecture, and the metadata repository layer. So what they do is they record the information regarding the files that are being stored, the file locations, reference to the certain versions of the data, all those things, and these are all encrypted. So in addition, like when any data changes happen, the metadata repository, it automatically updates to provide a pointer to the changed data. So all of this is performed like background by a software without any involvement of the user. So basically the metadata repository still retains the record of all the versions of the dataset. So this is how like zero copy cloning work in Snowflake. So that's another important feature.